Hello everyone, I am Dr. Sirajul Akfazi. I welcome you in my YouTube channel. Today in this video, I am going to talk about basics of computational chemistry. So I will discuss about introduction, basic guide to computational chemistry, application to investigate of molecules, application to investigate of chemistry and future direction. So let us start learning of quantum chemistry by introductions. Role of calculations. Calculations are much like experiments in that both may be employed in two different ways. Data collections, looking for the unusual. So first, when you are talking about anything, go through both aspects, advantage and disadvantage. If anything have much more advantage, then definitely it will be useful. If you have anything have much more disadvantage, so we are avoiding such type of calculations. So what is the advantage of calculations? Why we are interested to do calculations? You know, my friend, calculations can be performed on unstable molecules and reaction transition state. Unstable molecules, when you are synthesizing in the laboratory, you are not getting the results properly through the spectroscopic analysis, because the molecules are unstable. It is what you are expecting, actually that is not the structure of molecules. Now transition state, very important. You know about the transition state theory. You know the activation energy. So experiments are very difficult on such molecules and cannot be performed on transition states. So calculations are becoming less and less costly. Experiments are become more and more costly. Now try to understand this term. Calculations are becoming less and less costly. Experiments are becoming more and more costly. So advantages of calculations. Calculations are safe. Experiments are sometimes dangerous because you don't know the properties of molecule. So go through with the virtual calculations, simulations, then you have to perform this experiment in the laboratory. Calculations are now easy to perform. Experiments are sometimes more difficult. So calculations are now performed by not only the computational chemist but also experimental chemist. Now disadvantages of calculations. The cost of calculations increases rapidly with molecular size. The cost of experiment is generally independent of the molecular size. Calculations sometimes yield different results depending on the employed model. Experiment usually provide only one result. And this is the disadvantage of calculations. So basic guide to computational chemistry is molecular mechanics methods, quantum mechanics methods, semi-empirical, ab initio Hartree-Fock, ab initio correlated Molar-Plisset, and density functions. My friend, what is the differences between molecular mechanics and quantum methods? Molecular mechanics are restricted to the description of equilibrium structure and conformations. Quantum methods also provide information about non-equilibrium forms, transition state, and about electrons charge distribution. So differences between molecular mechanics and quantum mechanics. What is the molecular mechanics here? Molecular mechanics are based on the use of experimental information, that is the parameters, and thus cannot be applied outside the range of the parameterizations. And quantum methods are not based on the use of experimental information. It is not like that you have to take this 5 ml and 10 ml and do the experiments. You have to maintain this temperature. So experimental information and thus can be applied to areas where there is a little or no prior experience. So molecular mechanics methods are much less costly than even the simplest quantum method such as semi-empirical method. So range of molecular mechanics and quantum methods. You know the methods: molecular mechanics, semi-empirical, ab initio Hartree-Fock, ab initio correlated, density function DFT. So range heavy atom greater than 1000 for molecular mechanics, less than 200 for semi-empirical, less than 50 for ab initio Hartree-Fock, less than 20 atoms for ab initio correlated, and less than 100 for density function. So relative computation time. You know, level of calculations, single point energy, and geometry optimizations. If you are using the level of calculations FF94, that is the F and F. I will discuss about this. AM1 semi-empirical, geometry optimization 0.06. Hartree-Fock 321G ab initio. See the timing. Hartree-Fock 631G star ab initio. See the timing. MP2 631G star. See the timing. Ab initio correlated. And PBDN star DFT you can see. The timing now deduce. Geometry optimizations. So comparisons of the performance of molecular mechanics and quantum mechanics. You have the tasks like geometry, transition state geometry, conformation, and thermochemistry. A satisfactory and U unsatisfactory. So you have two terminology here. If you are using the molecular mechanics and if you are doing the task geometry optimizations, then satisfactory, conformation satisfactory. If you are using the semi-empirical, you are doing the geometrical optimization with the help of semi-empirical, you are getting the results which is satisfactory, transition state is satisfactory, conformation unsatisfactory, and thermochemistry unsatisfactory. Same way, if you are working on the ab initio, Hartree-Fock, and density function theory, what results you are getting here? You can think about that. You are getting the satisfactory. So this is the best methods. So references of MM and QM. Review of MM, you know you are using this paper. Go through this paper and read it out. And review of basic quantum chemistry, go to the Levine. Review of semi-empirical method, go to this paper. Review of Hartree-Fock, go through this paper. Review of the density function theory, you have to consult this paper. Now, you should know some software like KM3D, Gaussian, Mopec, Sybil, Spartan. This is the wave functions. Each software has different users in interfaces, operating feature, price, manual, and so on. So application to investigation of the molecular structure and property. You know the investigation of molecular structure by use of molecular mechanics and quantum mechanics. You know the geometry, you know the absolute configurations, you investigate of molecular properties like electron charge distribution by use of quantum mechanics. So, my friend, investigation of molecular structure by use of molecular mechanics or quantum mechanics. First, ask geometry. Geometry means what? Bond distance, angle, energy of molecules. Conformational energy differences in 1,3-butadiene investigations of order of stability. Look at here dihedral angles 0, 90 degree, 180 degree. So what will happen if you are changing the dihedral angles? S cis and S trans, then two state. So relations between dihedral angles and relative conformation energy in 1,3-butadiene. Look at here the situations. S is, now you see the two state situations, how much energy have the two state. And then look at this S trans. So order of stability S trans is much more stable than S is and than two state. Why? Due to only dihedral angles. So absolute configurations. Physical method, you have the X-ray crystallography, you have the CD, circular dichroism, spectroscopy. You have the chemical method, total synthesis. You have NMR spectroscopic like 2D NMR, 1D NMR with chiral derivatizing agents such as moisture methods. You have the computational chemistry like molecular mechanics and quantum mechanics. So advantage and disadvantage of X-ray and CD methods. What is the advantage? You know, my friend, these methods have high reliability. What is the disadvantage? And these methods have limitations of application. Prepation of single crystal, molecules where pi electrons, chromophores exist or can be introduced, CD methods. So advantages and disadvantages of total synthesis. Advantage, this method has high reliability. And what is the disadvantage? Long time, many synthetic organic chemists. So now you understand the challenges of chemistry. The advantages and disadvantages of NMR, 2D NMR, 1D NMR with chiral derivatizing agents. What is the advantage? NMR is widely used and easy to perform. What is the disadvantage? Low reliability on a cyclic system as well as the macrocyclic system, 2D NMR. Preparation of derivatives by use of chiral derivatizing agent, Mosher's method. My friend, advantages and disadvantages of computational chemistry. I already told you, disadvantages attached with the every methods. So advantage, this method does not require preparation of a specific sample in contrast to X-ray and Mosher's methods. And what is the disadvantage? This method requires combination with the another method such as NMR. Quantum mechanics has limitations of molecular size. So determination of absolute configuration in a macrocyclic system by a combination of computational chemistry and another methods. So look at sarcopene. Reaction with the selenium dioxide at room temperature, you are getting HMBC and NOZ of these molecules. These HMBC and NOZ is the 2D NMR. Now, the distance between hydrogen 2 and hydrogen 13 is 4.0 angstrom in 13 R configurations. So this is not the consistent with the information based on the NOZ. Now the distance between hydrogen 2 and hydrogen 13 is 2.4 in 13S configuration. So this is consistent with the information based on the NOZ. Now CD spectrum, what you are getting the informations. Negative Cotton effect. What does it mean? CD also support 3S configuration, 13S configurations. So investigation of molecular properties, electron charge distribution by the use of quantum mechanics electrostatic potential, atomic charges, dipole moment, enthalpy, entropy and free energy, and solvation energy by investigation of basicity, proton affinity, acidity and much more. So my friend, 4-aminopyridine, where is the basic site? The quantitative investigation, if you look at this molecule, how it is react with the water and under equilibrium, and it is in the NH2 form, here in the polar form. Now this hydrogen is transformed from one nitrogen to another nitrogens, and all this hydrogen transformation under equilibrium, and del H is 193.6 and here del H be 106.9.1 kilocalorie per mole. So B is more stable than A, and thus the ring N is more basic. So my friend, qualitative investigation electrostatic potential map, look at here. The color near red represents more negative charge, while the color near blue represent more positive charge. Now you understand the meaning. The ring N is more negatively charged and thus is likely to be more basic. So imidazole, where is the basic site? Electrostatic potential map. Look at here. The N3 is negatively charged and thus is the basic site. Now you understand how beautifully you can understand things by use of computational chemistry. So addition of alcohol. You see the methanol, ethanol, 2,2-trifluoroethanol, phenol, 2-nitrophenol. You have the different pKa's, acidity. Now you stronger, weaker, how you will decide? So electrostatic potential ESP map for the alcohol. You can see ESP electrostatic potential map for the alcohol. If you go through this four structure, ESP map shows that acidic site are positively charged and it reflects the relative acidity, light versus dark blue. So application to investigate of chemica, you know, investigation of molecular orbital by use of quantum mechanics. When there are more than one reagent, which reagent will react first? It is a challenging. When a molecule contains multiple reactive sites, which site will react first? Examination of frontier molecular orbital, HOMO and LUMO, is an important method because most chemical reactions involve electron movement between them. So references of frontier molecular orbitals, FMO, theory and reaction, you have to go through this: Fleming, Fukui, Gilchrist and Albright. So my friends, examination of FMO energies, very important. Frontier molecular orbital, FMO. A reagent with the highest HOMO energy will give its electron most easily and thus be the most reactive donor. Very important. A reagent with the highest HOMO energy will give its electron most easily and thus be the most reactive donor. A reagent with the lowest LUMO energy should be able to accept electron most easily and thus be the most reactive acceptor. So Acrolein, what is the role of Lewis acid here? BF3. So Lewis acid are commonly used to accelerate chemical reactions. The BF3 adduct of acrolein more rapidly undergoes nucleophilic attack than acrolein itself. So what will happen? What they are doing here, BF3? Now you understand. So LUMO energy is 0.19 electron volt. You see the HOMO nucleophiles, a small gap, more reactive. So acrolein BF3, you can see low energy in acrolein. So orbital energy, if you go through this, you will find it out. So Lewis acid complexation reduces the energy of LUMO on acrolein, making it more accessible to the HOMO on nucleophile. So my friends, investigation of chemical selectivity, examination of FMO shapes value, the regions where LUMO shapes value is larger will be reactive site toward the attack by nucleophile. The regions where HOMO shapes value is larger will be reactive site toward the attack by an electrophile. So ester enolate, where is the reactive site? You know my friends, the ester enolate has two possible sites which may react with the electrophile, the anion and the terminal carbon. Look at here. Here CH2 where electron releasing group is attached. E. Now look at the situations of these three. The site where HOMO shapes value is larger will be more reactive toward the attack by electrophile. Now, the color near red indicates minimum value and the color near blue indicates maximum value of HOMO. So what does it mean? If you go through this HOMO of the enolate and HOMO map of the enolate, then you will understand the situation of CH2O- and the terminal carbon where HOMO shapes value is larger generally react with the electrophiles. My friends, electrophilic substitution of indole is a challenge and very good chemistry here. What should be favorite position for the electrophilic attack? So HOMO map reveals that 3 position is the most likely site of electrophilic attack. Now stereochemistry of nucleophilic addition to carbonyl compounds. So cyclohexanones has 2 possible phases which may undergo a nucleophilic attack, the axial and equatorial phase. Now think about it. You have the situation like up and bottom. You have the situation like both sides, from top, from the bottom. You have 2 situations here, an axial and equatorial. So how nucleophile approach towards the carbons? The phase where LUMO shapes value is larger will be more reactive towards the attack by the nucleophile. So nucleophilic addition to dioxanone rings. Look at the LUMO map for the axial phase and now LUMO map for the equatorial phase. Did you understand the differences? So which one is suitable? Which is the perfect? The nucleophile preferentially attack from the axial phase, not the equatorial phase. So nucleophile addition to dithianone ring. This is also very important ring. Look at the LUMO map for the axial phase and LUMO map for the equatorial phase. Now you understand? Nucleophiles preferentially attack from the equatorial phase. Now these 2 terms, it is very clear to you how axial and equatorial will function on the basis of the calculations. So future directions. Calculation in solution. Although the calculation in gas phase usually provides a reliable account, it in solution is still unsatisfactory for the investigation of some tasks. The development of several methods is in progress for the calculation in solution. So preference of the recently developed method for the calculation in solution, a lot of paper, you go through this paper. So extension of application field of computational organic chemistry like molecular mechanics and quantum mechanics calculation have been used to mainly in the field of investigation of molecular structure and chemical reactions so far. So explosive developments in computer hardware and software. So they have recently begun to be widely applied is not only organic chemistry but also biochemistry and closely related fields such as drug design. So my friends, references of drug design by use of quantum mechanics, go through this paper, very important paper. You will learn a lot of things here. So quantum chemical calculations are expected to become an important method for drug design in future. So my friend, if you like such type of video, then subscribe my channel, and thanks for watching.